My name's Gareth Jones. I'm an API architect at Microsoft. And I've been there a little over 21 years, which sounds a bit insane when I say it out loud. But I've spent about the last 6 years working on APIs. And the last couple of those working on our education team, building a platform for people who are building apps targeting the classroom, so whether that's K-12 or higher education. And I'd like to spend about this last half hour talking to you about the state of, and maybe the limitations in where we are around API descriptions today, and particularly in terms of how we deal with unexpected change. Sound good? So, here's my scenario. You're an API owner. So how many people here own an API or contribute to an API? Yeah, quite a lot of you, probably about half, right? So, you're feeling pretty good about it. So, of those of you, put your hands up again. So, keep your hands up if you've got an OAS or Swagger or some kind of formal description. Wow, almost all of you. That's awesome. We've really got it, right? We're doing it. Best practices, we're really smug, right? You're feeling pretty good about yourselves with your hands up right now. You've generated some SDK because you've got an OAS, right? You've got loads of automated tests running against that API, and you're monitoring it from all around the world. What could possibly go wrong? You are a best practices god. It's not going to be a good next slide, is it? No, it's not. So you deploy a new build. Tickets start flying in. And you're still sending data that just matches your spec. That's what's coming in. All your tests are still green. Sad unicorn. And your boss is not a happy person. So what has gone wrong? You were, best practice god just before you deployed. Now you're a sad unicorn. I don't know. What could possibly have gone wrong? Well, really, whether your API is public-facing or whether you're internal, as Alan said, it comes down to being a provider-consumer model. That's what we're doing here. Having a contract gives you a lot of internal benefits as you're the provider in that. It gives you a foundation to build on, to hang your tooling on. It gives you a way to drive your own quality around tooling and decide whether you're sending a correct payload in and to build tests around that and be sure. Does it? I don't know. Something just went wrong and everybody's breaking. It doesn't seem like it's giving us quite as many of those benefits as we thought. So the problem is, it's a contract between provider and consumer. And like all contracts in any form of life, the looser that contract is, there's more wiggle room in that contract. The more room there is for interpretation. And the more room for interpretation, the more can go wrong. And I'm here to tell you that our current API specification languages have got a lot of room for interpretation in terms of behavior. So that interpretation really obviously can happen on both sides, between the API creator, but really the person who's feeling the pain of that interpretation tends to be the API consumer. They're the one who has no idea that you just shipped a new build. They don't know what's coming down the pipe at them. If something does go wrong, they don't, and the contract hasn't explicitly changed, they don't know, should I be calling you up? Have you changed the contract and not told me that you've changed the contract? What's going on here? How can they interpret it? But there's another angle to it as well. It's not just marmalade cats that are lazy. This one does look pretty lazy, I admit. People are busy when they're consuming your API. Your API, sad to tell you, is not the top of your customer's mind. It's just the thing they're getting on with in their job, and then they're going to move on to the next thing. They probably, when they used your API and consumed your API, just took the very first sample at the top of your documentation, or they made an account in your system, and the first packet they got back is what they coded up against. They didn't examine the contract in enormous detail in many cases, or if they did, may have not looked at it in quite as much detail as you would have liked them to. It's just human nature, unfortunately. So that interpretive piece just gets worse and worse, and especially when we can't express everything we would like to express. So we just have this code that handles consuming our APIs in a way that we wouldn't ideally like if we'd written it as producers. But we're not there to hold our customers' hands. We can't be. That's what we're trying to do in a more loosely coupled API economy, is create something that's much more self-service in these business relationships. So we tend to focus on this notion of breaking change and say, well, what I'm going to do is I'm not going to have any breaking changes in my API. It's breaking changes that hurt my customers. But we've got to define what breaking change means. And then we say, well, I've defined what breaking change means. Perhaps it means I'm not going to remove anything from my API. I'm not going to change the name of anything, and a bunch of other things that we set down as rules. And then we say, well, anything outside of that, well, that's my consumer's problem, really. Is that an okay position to take? We're trying to set up a business relationship, as Alan said. Well, we want that business relationship to succeed as the API provider. The stakeholders in that, things are a bit unbalanced, right? It's really on us to make sure that there's some degree of smoothness there and some degree of business continuity. So we've got to define what we mean there. So there's this constant tension between, well, if I didn't change anything, none of my customers would break. Easy. But my business and even my customers are saying, well, I want new stuff. Cool new stuff, give me the cool new stuff. Those two things are in complete conflict. So you've got to design what a breaking change bar means for your business and your organization. Do you want to balance that breaking change bar to be around business continuity as an absolute, really, really high bar, and really be extremely super careful about breaking your customers? You might have it at one end. Or do you want to move fast and break things, as somebody once said? Wouldn't necessarily recommend that in today's economy, but there is, there's a sliding spectrum there. The important thing, I didn't mean to go forward there, is design the thing, right? Choose it for your business. But you'd argue in some cases that whatever you do, you can't quite win. So Hiram Wright made this observation, a really great observation. It's come to be known as Hiram's Law, that when you start to succeed with an API surface, or indeed any interface to a system, that people will take dependencies, not just on your interface, your defined interface, but the internal behaviors that leak through. It's kind of inevitable that some of our internal behavioral implementation does leak through. And once you get enough customers, everybody's taking a bit of a dependency on some of your internal behavior. Get really enough customers, and every single bit of your internal behavior has become an implicit dependency that you never documented, you never put in your contract, but actually you've just created this de facto contract with all of your customers that basically sets in stone the behavior of your system, unless you want to take a break to somebody. That puts us in an invidious position, right? So what are some of these things that can leak through? Let's take a look at some. Well, the most easy thing that you can see leak through is the number of things in a contract. So we'll all walk up to an API contract and say, well, there's one of these, or there's many of these, an array or a collection of things, right? Easiest thing in the world. Set the sample data might often, in a collection, only have one. Because, it was easy for me to say, well, a customer has got one bank account. That was the sample that I put out. I put one in the collection. I expected somebody to notice the square brackets there. My caller of my API actually only coded it up to cope with one, because there was only one in the sample, right? So why would they need to code it for any more? Well, suddenly it grows to a lot more than one. They're only actually reading the first one anyway. And it's not just arrays and collections. The thing works at a larger scale as well. We've all got APIs that have got paging in them, right? Go and get the next page. But how many of our sets of test data that we put out to our customers actually have a second page of data? Anybody got test data that's got more than one page? Oh, gold star. I need to stop pressing this, don't I? People will very frequently code to your APIs with just the first page read. Happens an awful lot. It's not just the number of things; it's the sizes of things. So I might write an API that returns images. My test images from my test set of data might be, simple low-res images. You've seen my preference, right? They're clearly going to be low-res images of marmalade cats. But real data, production data, high-def images, great big things. Didn't code for things that could come back that size. Wasn't expecting to have to do a chunked pull on them. Doesn't work. Or just the JSON packet size might be overrunning some buffer. If I've got an IoT system, I might have some hardware buffer on a hardware-constrained system. Suddenly now my test data fitted into that, my production data doesn't. So my friend Dave O'Neill from API Metrics gave me this great example from a retailer who built an Android application. Their stack had a limitation in it. Their stack on Android had a 10 meg limit on JavaScript parsing. And that sounds quite a decent size, right? Turned out their production data went over 10 meg after a couple of months in production. Bang. Their app just died. So there's just so many ways that you can trip yourself up around that. And then perf. Perf kills us all the time, right? I think it's kind of obvious that people calling our APIs don't like it when we suddenly ship a version of our API where it gets slower. It's just an unpleasant experience. Makes everybody's apps grind. But think about that from the point of view of sequencing. If I'm sequencing calls, if those are the calls that run at the start of a sequence, particularly if they run at the start of every sequence, like some call to get identities or something that I'm going to use later on in typical sequences, I could really mess somebody up by making that one slowly. But here's what's even worse. I can break my customers by improving the performance of my APIs. We'd all think, going and doing a perf improvement is a good thing, right? But what if my customer's application was written against me running at about this kind of latency? I squish the latency down to that, suddenly I've uncovered a race condition in my customer's application. Well, I don't know whose bug that is. It certainly doesn't feel like my bug, but nevertheless, the customer's application is suddenly broken because I did a deployment. Again, horrible, right? And there wouldn't be an API presentation without me talking about, auth somewhere. Auth is usually one of the worst things to get onboarded to an API, and it's certainly one of the things that trips people up when changes get made. It's not usually something people bother putting too much detail about in their OAS documents. You can put some basics in there, but the detail, not so much, right? What if, and something, in fact, a huge number of things, there's just nowhere to specify that. So what if somebody goes and changes at the IDP the maximum time or the default time for an access token? I was, as a caller, expecting to do a certain amount of work while that access token was valid. Suddenly now, my application runs out of token halfway through my workflow. Now, clearly, I shouldn't have written it like that. I should have gone and got a refresh token if at any point the token ran out. But I never needed to before, because it used to last for 2 hours. Now it lasts for 30 minutes. I didn't bother writing that refresh token flow. Have I got to go and put that in? Well, I just broke your app. What if I've got role-based security? We heard about some of the dangers of that earlier. So maybe I had a manager role and a user role before. Obviously, managers can do more than users or see more data in some cases. Now I go and add a human resources role. Well, presumably the roles of managers and users, maybe managers' roles have subtly changed if that was all there was before. They've got less permissions now. Some of their permissions have been moved into the human resources role. So now the manager app is subtly broken until a user gets moved across. How do I communicate that to people who've got to now go and move things around in the corporate directory? That's not even the app that's got to change to do that. That's the IT department of the people who are using the app. That's a really invidious way to break people. So there's just huge numbers here. We had Travis telling us earlier that apps shouldn't be poking into access tokens, but they do all the time. People go and look at the contents of access tokens. As an app developer, I'm absolutely within my rights to go and just take stuff out of access tokens. They're supposed to be private to me. But because they're just JOTs most of the time, everybody pokes into them. Take something out, boom, I just broke somebody who was depending on that thing that they shouldn't have looked at in the first place. Then things that are completely outside of your control. So over the last couple of years, we found that it's not super great to use embedded browsers on mobile apps for sign-in. We switched over to using new tabbed windows instead across IDPs, such as ourselves and Google. That broke any number of applications, and people were just picking up a new library. Well, they're, again, broken app. Who's looking after that from the point of view of business continuity? Webhooks, another great source of pain. People will often write a sync for webhooks that's, how can I put it nicely? Tiny bit primitive in its coding standards, should we say, or quality. Hey, I'm only getting a few hooks from you now and again. I can process those in line. It's only a couple of lines of JSON to read and not much business processing. I can just do that. Obviously, the best practice would be to throw it on a queue and process it in some backend later and just get back to the webhook server, right? But you didn't send me much data, so I'd just do it quickly here, over here. Nobody's going to notice. Yeah, you see, now I was only sending you, let's say, account created and account deleted webhooks. There wasn't much data in those. But now, as an API provider, I've decided to send you account changed webhooks as well. Great new feature, right? Might have just upped the volume by an order of magnitude. Your not so great little bit of hacky code over here now probably just fell over in a heap, because it certainly can't cope with 10 times the calls that it was getting without going and putting them onto a queue properly. Or maybe I've just put a whole lot more data into the actual packet which needs to be parsed. Very easy to break people. Not because you did anything wrong, but they could get away with something beforehand. Hypermedia is a fun one. So we have this assumption for people who are building a hypermedia API that we can navigate to pretty much any URL. All of that comes from the thought of calling things and working inside a browser. Users in browsers can pretty much go where they like on the web on the whole, right? And this might not even be a real deep hypermedia API. It might just be that I've got something like an image download which I want to take into a different subdomain when I'm pulling, or to send you off to a CDN to go and get an image, right? That's a pretty common thing to do, to go and get static data. My ear's falling off. But if my API is in a server-to-server call, well, servers are often locked down to which URLs they can call at the point when you decide to actually go and configure the production servers. I only need to call the APIs that I'm calling. So from a security point of view, why would I want my server to be able to just make random calls to anywhere on the internet? That doesn't sound like an enormously marvelous idea. Certainly plenty of IT departments think that way, but then you just change it, because it's hypermedia, right, to say, oh, I'm going to a different CDN, or I'm sending you off to a different subdomain. Bang. We've all got query parameters in our APIs for one thing or another. Loads of people have got quite rich languages built in query parameters. I own an OData API that's got a full query language built into query parameters. I can document that a query parameter exists in my OAS. I can't document the subtle interaction of those query parameters. So I might have filters, ordering, for a sort order, the actual sort parameters, all sorts of things, counts. Does one work with the other? It's very easy for me to change that on the back end and say that, well, if I've sorted by field X, I then can't filter by field Y or vice versa. That's a very easy change. Or I've dropped a database index somewhere deep in a back end, and now mysteriously, I can't filter by that column at all because actually I need a database index to be able to do filtering, and if the index doesn't exist, I just refuse it. So that's suddenly 500s. No way that's going to be in my contract. So super, super easy to break people with that. All right. Hopefully I've convinced you that there's any number of ways that you could have a beautiful, beautiful OAS spec and still just break your customers. And that's why we were here, right? We don't want to break our customers. That's part of why we created an OAS spec. And we might have created it because we wanted SDKs, or because we wanted to connect into some testing tool that used to parse it. But one of the things I'm here to assert is that the reason we create them, or the reason we will create them over years to come, is to have a machine-readable contract for how our business behaves externally, or how two departments inside our business speak to each other. We're really talking about a business relationship here and describing how businesses interact through APIs. So we want to be able to understand how we can get there, how we can get to the point where we don't break our businesses. Now, we could go and use the extensibility. OS has got very rich extensibility, and try and start to document more of these things, and then over time drive them into the spec. And I think that's a good and right thing to do. But the reality is, at the moment, tools that consume that OAS probably won't understand those extensions. So unless you're building a very rich tool chain yourself, and not everybody is a tool builder, right? Then you're not necessarily going to get an awful lot of protection from that. Still would encourage you to do it because it documents it in a way that will encourage tool builders. And we can start to have a conversation as a community about what's needed and what needs to go in to improve the OAS. But it's not all you can do. So let's talk about some things you can do. So I coined this term. I actually coined this term this morning when I was fiddling around with my slides. The idea of a chaos mock. So we heard a bunch today in various talks about tools from, I think, pretty much all of the vendors in the hall out there will support mocking of APIs. And then we heard about the idea of creating a fully fledged API emulator earlier, something that perhaps has a little bit more code behind it to have more of the behavioral characteristics. So what if we take this idea a bit further and say there's huge amounts of variability? You've heard me talk about the different kinds of variability in behavior. Let's embody that in a mock that expressly makes it unpleasant to call my API. At the time when I'm developing against it early on, when it doesn't matter if it's unpleasant, I want it to be unpleasant. Maybe not for the first call, because that's going to put people off, and I'm sure the DX people in the room are going, don't a first call. But, once I've got past that, I want my app to work in production and fail in development, not the other way around. So let's have a mock that spits out calls that are fast and calls that are really slow. Let's have a mock that goes and fills in every collection with something that's huge, something that's completely empty, something that's only got one in, that does multi-pages and single pages, that goes and works out the domains of all your enumerations and spits everything out, and then spits out all the possible combinations. So there's a technique called model-based testing that uses finite state machines to call into things based on definitions. I think what we want here is essentially the exact inverse of that, to provide a mock that uses a finite state machine to provide the answers to APIs. I don't think this thing exists yet, so it would be awesome if all you vendors in the audience would put your thinking caps on and that'd be the next cool feature. But I think this is going to be the thing that really adds the most value to us being able to say to our API callers, hey, if you can work against this awful, painful mock, then you've got absolutely every chance that you're going to be golden in production. So what else? A lot of the things customers send us in query parameters or in headers, we treat as gospel. Yes, you asked me for the top 10 items in the top 10 rows in some query over a collection or something like that. Well, it's not going to be gospel in production, because if there's only 3 left in the database, I'm only going to return you 3, right? I'm not going to simulate the last 7. So let's be doing that. Let's send you 5 twice instead of 10. Let's not obey these things. A lot of them are actually, and particularly if you look at the standards that they're conforming to, are actually just suggestions anyway. They're effectively hints to the server. Treat them as such. Again, particularly if you've got a pre-production endpoint, there's absolutely no reason not to make sure that somebody has coped with all of those cases that they will encounter in production. So really all I'm saying here again is just try and get all the things that might happen in production out way, way earlier. And then hopefully this one is kind of teaching you to suck eggs, right? You're going to be deploying, you're going to be looking at your logs. But you might be tending to look more for, are there any new errors, any new 400s, 500s particularly? I'd encourage you to look a bit deeper than that. Have you got more calls than you used to have in the hour before you deployed, in the hour afterwards? You might be inclined to celebrate that because you're just very much in a mindset of, oh, more calls, better, yay. Well, you haven't done any marketing in the hour after you deployed, I wouldn't think. So, oh, you might have if it's some big launch, but you know what I mean. Generally, for a regular daily or weekly or whatever your schedule you're on deployment, it's probably a sign that something weird is happening. Certainly if there's less calls, that's a pretty bad sign, right? Some sequence of calls that users are normally doing is probably failing partway through and you're getting a lot less calls. And what about the packet sizes? Do you routinely monitor those? If they go down or wildly up after a deployment, were you expecting that? I've got a great example of that in a minute I'll talk to you about. But look more closely. Look at metrics in those logs that you weren't expecting to. So, I said earlier, define your breaking change bar. I think this is the thing, right? I've brought out a lot of cases. I'm sure you've got others from your experience. Consider them as whether they should be part of your breaking change bar. Think about where you are on that business continuity spectrum. If you're hypersensitive to it, consider putting some of these things into your breaking change bar. It might feel really weird to say, hey, we need to version our API because we now return 5 things in an array, whereas previously we returned 1 thing into an API, into an array. That does feel pretty strange, right? You're still conforming to the contract. But if you've got an inkling that that's actually going to break people, well, that was the definition of a breaking change bar, right? It breaks people. So if you think it is, maybe it should be in your breaking change bar. Be talking to your, if you've got an API product manager, be working with them and define that. Understand what your business's sensitivity to it. That's really what I mean by define it. And I'm sure you'll be at very different places on that spectrum, but make it work for you. And don't be afraid to version your API because of untraditional things. So, one last thing, to borrow a phrase. You see that red box? That's the real API. Again, I thank my friend Dave from API Metrics. You see hopefully you can all see it, there's a drop-off in the blue line. So the blue line is the payload size for an API. This is the API for a bank in the UK. It's the API that lists all of their ATMs in the country. It's kind of a good idea if your API works when you deploy. So the API, at the point where that blue line dropped, met its contract, was returning a 200, all the tests were green. Everything looks good. The only problem was, if you look at the packet size, the list of ATMs that was coming back was now only returning the ATMs from 1 town in the country. Oops. So make sure your API actually works still when you deploy. That's probably the biggest breaking change bar of all, right? If it doesn't work, you've pretty much broken people. Okay. So, hopefully I've given you some food for thought that, we might all feel like we've, evolved over the last few years to the point where OAS has kind of won the API spec wars. Many of us are doing it. We feel good about it. We are still on a journey. We can make the spec better. We can all decide what the right place for us along that spectrum for our business is. We can push for a better fitting ear cuff. We can push the spec forward, particularly. So thanks ever so much for your time, and I'll let you go and get some drinks. Cheers.